We're going to learn today on supervised learning. So supervised learning basically is an important topic in multimedia retrieval for machine learning, for the AI, and it is used to support the multimedia retrieval. It is about image retrieval, object, identifying object, naming the object. So supervised learning is an important technique in multimedia retrieval as well as in artificial intelligence. Okay, so we need this one. So this is the book I refer on the supervised learning chapter 2. If you look at this scope, so the whole is AI. Okay, we got AI here. All right. And inside AI, there is a component called machine learning. Okay. And under machine learning, you got a supervised learning. This is a supervised learning. Okay. And you got reinforcement learning. You got reinforcement learning. And you got unsupervised learning. Okay, unsupervised learning. Okay. And you got deep learning. Okay. So you got 1, 2, 3, and basically 4. Okay. So we got supervised and unsupervised. So between these, you got supervised and unsupervised together. And you got self-supervised learning. It do it without human intervention. So basically here, what I need you to know is just a scope of where is machine learning is located on the field of computer science. Okay. So note that these supervised learnings are under artificial intelligence and machine learning. Okay. So remember that. Okay. But this is a powerful method. All right. Okay. Let's forward. Let's move on. Okay. Supervised learning basically. So supervised learning basically is under machine learning. Okay. Artificial intelligence means a computer that has intelligence. Computer that has intelligence to solve the problem. Okay, that's artificial intelligence. So the computer has sort of intelligent element, not a very straightforward if then else, but it has intelligence. All right, such as predict, do some prediction. Predict that today gonna be rain, and the prediction is more accurate than human. That's artificial intelligence. You can predict the team will win the game, and the prediction is more likely happen than the prediction of human. So that's artificial intelligence. You got a software, a computer science that has an element of intelligence in making a decision, which is human do. Okay. And machine learning basically is a method to support the artificial intelligence. Machine learning basically is a machine that can learn something. Machine that can learn basically means you give the machine data, 1,000 of them, they can see the pattern of the data. So they can learn from the data. The machine that can learn from the data. Okay, machine learning. When the machine is given 3 years of data of the bank customer, so the machine can learn of the pattern of all the customer of the bank, their behavior, all those things. So machine can learn from a large amount of data. And machine learning basically is divided into 3. Supervised learning here, what we're gonna learn today, and unsupervised learning and reinforcement learning. So supervised learning basically we're gonna touch on this one only. Okay, and we are not doing this, and we are not doing this. Okay, you can learn it some other time on your own. So once you know the concept of supervised learning, these two are become easily understood. Okay, to adopt. All right. So supervised learning basically the application can fall under classification or regression. Classify. So this is this are type of class under supervised learning. So supervised learning can solve the problem of classification, can also do some form of regression. Classification basically just simply like a fraud detection, whether it is fraud or it is genuine, whether it is spam, it is not spam, whether it is cancer or not cancerous. Image classification, where it is a dog or it is a cat, where it is a dog, a cat, elephant, and so on. That's classify. You're going to classify into certain group. Image classification, I'm going to classify the animal between 3 animals. All right, for example, 3 animals: cat, dog, and snake. So 3. You can go for more: cat, dog, snake, elephant, and so on, until up to you, 10, 20. Let's look at the word classify. You classify the things, okay? Diagnostic. So how many groups you want to classify? I'm going to 2, COVID-19 or healthy. All right. Regression. So these are more range a bit. So you got a score prediction. So you got what score I get on this exam. 20, 30, 40, 50, 60, 70. So it's a regression. You know, that's some regression. But it is more linear. The score that you're gonna get. So you got 0 to 100 prediction. 0, 1, 2, 3, 30, 14, 80, 90, 70, and 100. So it is more linear. So the word learning here is important. Okay. The machine that can learn, data given to you based on the application. If the machine are given fraud detection data, so he can predict about fraud detection. When the machine is given spam detection data for 3 years, so the machine can learn for 3 years and making a new decision. When the machine is given to the X-ray data about 500 X-ray or 1000 X-ray of COVID-19, machine is given 20,000 X-ray of COVID-19. So the machine be able to learn the pattern and later on be able to make a prediction of COVID-19. Okay, so that's what you call machine learning. Okay, so that basically what is machine learning and supervised learning introduction. Okay, the application of machine learning basically be able the software to do the following tasks like human do. Okay, so like describing photo, recognize object, X-ray diagnosis, recognize face. So these are tasks human do. Okay, let's look one by one. What is the object in the photo? So this is multimedia retrieval. Please retrieve the object in the photo. What object in the photo? But first of all, you need to see this is object here. Can machine recognize object better than us? The machine can recognize this. Supervised learning be able to recognize this is what. Okay, we human basically we don't know what is animal because we don't have a clue what it is. But when you let the machine learn, it can recognize this. Even it is only show half of the body. Okay, only half here, but it can recognize. Okay, so supervised learning be able to do this. Okay, it can recognize the object, and it's been shown that Microsoft has show that the supervised learning through the convolutional neural network, the supervised learning be able to recognize object better than human. Okay, so if you look at here, they got a 14 million images on 1000 level. Okay, so means that the machine is learn about 40 million images on 1000 object. Okay, on 1000 object. This is what it means. The machine is learn from 14 million images to this 14 million images basically is 1000 classification. Okay, 1000 classification, 1000 group. And when machine done this, he can recognize better than human. When given any object, the machine be able to recognize more accurate than human. So human is here 95%, and machine is about more than 95%. Okay, so that's I think supervised learning is very powerful today. And during the AI supervised learning method technique is been heavily used. Okay, and so this is the paper of in 2015. Okay, 2015. I think now it's 2022. I think machine as far better than 2015. I think now it's been improved a lot. Definitely, he better not just only identify object, like him making decision, also even driving as well. Okay, and okay. So this is another one, supervised learning being used. So this is what we call YOLO. So what is this application basically? So okay, there. Okay. So this is what we call YOLO. Okay. So basically, the YOLO use supervised learning. He can identify object. He can detect there is an object, a lorry there, and he can name in it truck. So this is classification. How many you classify? Truck, car, motorcycle, and so on. Okay. So it use supervised learning. Okay. This is what we call YOLO. You only looks one. Doesn't matter about the name. The name is just simply you only looks. The computer only scan the image only once, then he can detect all the object and name the object. So this is user supervised learning. Okay, supervised learning is very powerful. You can do this. And this application basically is available in Google Internet. Basically, you can just download and install, and it's work because the machine has been YOLO has been learned of million of images. Okay, and he be able to detect the object here, and later he be able to name the object. In this case, he detect the object first. He scan all the image and he detect there is an object here. And what is the object? And you do use a supervised learning to classify this is a horse. And there is another object found here. And what is the object? The object is a person, and so on. Okay, so we use supervised learning. Okay, so these are YOLO light, mean a bit simple. Okay, so you can have this is the paper. The YOLO is about 2018. It's just a new things. Okay, you can identify many things. You use supervised learning, and this is about describing photo. Okay, given a photo like this, a computer be able to come out with this sentence. Okay, not human. A computer be able to come out this sentence. The girl is riding a horse at the park. She is wearing a blue shirt, jean, and pink shoes, and etc. So the computer be able to detect there is a girl here, okay, and horse, and seeing the girls on top of the horse, and the computer can basically derive a girl is riding a horse. A horse is a brown color. Then the computer can detect that the girl is a teenager, not an adult. Okay, and the girl is wearing a hat, and so on. Okay, so he can make the computer can make a sentence from this object. First, you're going to identify the object. So when you identify the object, basically is use supervised learning. Okay, so like this. Okay, describing photo. The first of all, you're gonna detect the object. Detect the object basically mean you retrieve the object. Retrieval. Okay, you're gonna retrieve a bottle. Find me a bottle of water on the table. Give me a cup of tea. So our course be able to detect there is an object there and retrieve. Yes, there is a cup of coffee on the table. So that's the retrieval, you know. Is there a flower on the table? And the system going to say, yes, there is a bouquet of red flower. Okay. So that's a multimedia retrieval. So it uses supervised learning. So here also you can describe the photo. A flower, bottle of water, glass of ice, cup of tea, fruit, banana, and tablet are grouped together on the table. So computer can say like that. Okay. Computer can say this is the picture of a group of objects called flower, bottle, ice water, coffee, tablet, banana, fork. And since it is see a person sitting at the table, so we can have a program to say that we can conclude that the person is having a dinner, okay, and so on. So you can describe this. When you're having this, you can describe the photo. All right. All right. This is the paper you're gonna have. It is from Stanford University on 19. I can't remember this. We have 2015. Okay, 2015. So that's that. You can read more. So this is 2015. I think 2020 today. It a bit more advanced than this. All right. Okay. Now we look at the supervised learning definition. Okay. We're going to look at the definition now. All right. I hope by now you got already know the power of supervised learning. Okay. So now we're going to look at the definition. We're going to look at slowly at the definition. Okay. The definition of supervised learning basically it is a process of learning through the observation of existing example and tasks. Okay. So it is a process of learning. Remember that it is a process of learning through observation of existing example. So these are two words. So in other words, supervised learning it is learning through the observation of existing example, and we human supervise it. We don't let the machine learn themselves, but we feed them example. We tell them this is dog. We tell them this is what, do this and do this. That's means supervised. The learning is being supervised. Okay. So the machine is the process of learning. The computer can learn from observation of existing example. The process it learn, we human supervise it. We human tell this is the step, this is the step, this is the step. You know? So that means supervised learning. Okay, everyone? You got it? Alright, okay. So supervised learning basically it is a learning. It is a learning, it is part of the learning of machine through the observation of the existing example. It can learn from the example so that the machine can have more knowledge and experience. When you can learn from example of data, the machine can be more experienced and knowledgeable. Because when he learns, he stores the pattern of the data. And the way it learns, we human instruct it. We not let it learn itself. We're going to tell the machine, this is the first step you're going to do. This is the second step. This is the third step. This is and the third step, and so on. Okay. So we're gonna tell the machine this is the first step, this is the second step, and now you do this, and this is the data. You learn this first, then you learn this, and try to predict this. That's mean supervise. We're gonna supervise the machine the step. First, okay, this is the data I got. Okay, analyze this one first. So you know, after analyze, okay, then this is next you are gonna analyze. And then you analyze. Then this is the next batch of data you analyze. At the end of the day, we finish the analyze, and that is supervised. Okay, that is supervised. Observation of existing example mean existing example mean data. You got image of dog right here. So this is example. So this is example of data. You got a picture of dogs. So this is example of data. Observation of existing example. Existing example mean this is existing example. Or you can have an example of 1 million bank customer. That's an example. Or you're going to have a 100,000 transaction of stock market. That's an example. Okay. You're going to have an example of people walking, the way they walk. So that's an example. Okay. And it is train the machine to recognize. Train the machine. This is another word. Train the machine to recognize a specific object such as dog simply by first providing the machine with an abundance of image of dog for it to learn. Okay, so the same like the above. So we're gonna train the machine in terms of so the learning is very basically we call it train. We train it. We train the machine. We train the machine until it good. Okay, we train the machine until it good. If we keep train the machine, sooner the machine will be better. You know, so we're gonna train. That's what we said. Train, basically just to train the machine. The more you train, the more it's better, accurate and perfect. So train the machine to recognize a specific object such as dog simply by first providing a machine with an embedded image of dog. So when we give this picture to the machine, he recognizes one by one. This is a dog. He recognizes the image. He analyzes the image. All right. The pattern of the image like this. The pixel is somewhere in the middle and blah, 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 blah. Then this is a dog. Then you're going to do again. So this is another pattern of dog. So you can have a circle like this, the same thing. And it is color brown. This is white, but you can see the pattern here. It is face round in the circle and ear on the thing. Then he's going to analyze this, analyze this, analyze this. At the end of the day, he can say that this is a characteristic of the dog. Okay. Simply just providing machine abandoned image to learn. Okay. He can learn. So we train them all together. So let the machine know that this is called a dog. So that's supervised. We let the machine know this is a dog. We tell them this is a dog. So mean that it is supervised. I'm not gonna let you learn yourself. So I'm going to guide you, supervise you during the learning. Okay, I give you this data. I collect this data for you. Then I said it is called a dog. So analyze it. So that's supervised learning. So we tell them what to do. So train mean let the machine analyze each photo which name is a dog. So you're going to go to each one. Okay, once the machine has sufficient learn, and then later you can recognize the name of new first photo. So when you can learn, when you give a new photo, he can say that this is a dog. Because when he analyzed this, it similarly look what he analyzed this. Okay, you got what I mean? So when you finish learn of this thing, sufficient learn, then later you can recognize the name of the new fresh photo. So this is the input. When it given to this photo, it can call it is a dog. Why? Because when it analyze this, the pattern sort of the similar what the computer has learned here. So that's why he call it dog. He don't know what it's all about. He just analyze the picture. When it analyzed the picture, the computer found that the characteristics of the picture are similar to the characteristic when the machine learned all this picture. Okay, and the similarity characteristic of this and what here basically is 98%. Basically, when it is 98%, mean it is very confident. You can call a dog. 98%. Okay, that's the supervised learning concept. Okay, so get used to this concept first. And now we have the role of features and label in supervised learning. Okay, and features, the role of features and label in supervised learning. So there is two words here. In supervised learning, you need to know two words: features and label. These are two important words that is compulsory for supervised learning. Okay. So features basically a unique form of pattern characteristic represent the image. So remember, features is a unique form, a unique characteristic, unique characteristics to represent the image. So in this case, if we got this image of dog, so we're gonna, dog is become a label. Okay, it's a label. Okay, so this is a label. You label this picture as a dog. It's just a keyword, or you can call a keyword to this dog. Okay, a tag. You can also call a tag to the picture as a dog. But here we use the name label easily for standardized. Okay, in supervised learning we use it label, so people understand when you say keyword tagging. It's also true, can, but weird. We don't use that. We use it label, so every people in machine learning know what this label is all about. So you label this picture as a dog, and the feature. So this number basically 62, 89, 42. So these are called feature. Okay. So these are called features. The pixel here represent a characteristic of a dog. So the pixel as overall, not just one pixel, the whole pixel. Okay, the whole pixel. The whole pixel basically is represent a dog. So that means it is the whole pixel is features. Okay. Okay, got it, everyone? So features and label are two terms very important for you to grasp in this supervised learning. So make sure features and label are the two important component in supervised learning that you must understand. If you don't understand the term label, what does it mean, and what features, you won't be able to do supervised learning later on. It's difficult to understand. Okay. First, you're going to know the concept of learning, process of learning. How does it appear? How a fresh photo, how to learn and train. Then, in doing that, you need to know the term features and label. Okay. So this is the image. So this is also the image. And now the features basically, I'm going to label it. I'm going to label this photo COVID-19. So this is X-ray image. I'm going to label it as a COVID-19. You can label it as what you can. COVID-19, cancer. Or you can label it as a paru-paru, tulang, dada. It's up to you. It depends on the problem you want to solve. In this case, I want to detect the COVID-19 from the X-ray. So I better label this is COVID-19 because this is a positive COVID-19 X-ray. If your application is about identifying what are the photo, you can say it is a chest. It is a chest, or it is, so it is classification. It is a chest or it is not a chest. Simply like that. It is COVID-19 or not COVID-19. Not COVID-19 mean healthy. COVID-19 mean you are got COVID positive. Okay, so this is label. All right, and Even it is a dog, you can label it as anything you like. Okay. Face, animal face. Okay, and so on. So the same like this. So this is the image of X-ray, and I label it as COVID-19 because my problem, I want to detect the COVID. If my problem is to detect what kind of photo here, then you can see it is a chest. All right, the features now is about, you can have this one. Okay, you can have contrast, homogeneity, correlation, and energy of this photo. You can have contrast, homogeneity, correlation, and energy. We got a formula to come out this name. Okay, there is a formula, but it is not we are concerned about today. So let's say this picture has contrast 0.02, homogeneity 0.9, correlation 0.9, and energy is 0.9 about this photo. So this contrast, homogeneity, correlation, and energy is considered features. Okay. So how many you got? This is the image. So image features can be contrast, homogeneity, correlation, energy, or another one is we call as a pixel. So this is the image. The image features can be pixel. The image feature also can be contrast, homogeneity, correlation, and energy. So you've got two options here. One, you got two options for the images features. One is what we call for contrast, homogeneity, correlation, and energy. This is one features you can pick, or another one is pixel. Okay, so you got two now features. So one features is pixel or this one. All right, two type of features there basically. And text. This is about text. You can see the difference. This is the image. This is a text. So you got. So what is the label here? Anyone? So the label, this is the label, okay? Play golf, yes or no. So the label basically only two. We only classify only two. Yes or no, that's it. Yes or no, play golf. If the label is just yes or no. Okay, no, yes, no, yes, no, okay. So the label only yes or no, only two label, yes, no. Yes mean you can play, no mean you cannot play. Okay, and what is the features? Anyone? So this is the features. Okay, windy, humidity, temperature, and outlook. So this is the features, and this is the label. The label is only two, yes or no. Okay, COVID-19 or not COVID, dog or else, dog or cats or whatever classification. Okay, they got yes or no, simply like that. Yes, it is fraud. No, it is not a fraud. Yes, it is a scam email. No, it is not a scam email. No, and yes. Okay. So in here, I want to develop a software called Can We Play a Golf Today? Okay, so the computer will predict yes. You can play today, tomorrow. I'm pretty sure 90% you can play tomorrow because he has a lot of data here. So here he has 11 data, 11 days, 11 data. So this is the first data, this is second, this is third, this is first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. So you got 12 data here to learn, 12 data to learn for the computer. So you can see the pattern here. How to say yes and no. Okay. So this is the tech. This is a video. Okay. A video is a little bit more complicated. And now we will look at the video. But basically, this is a video. Okay. You can have a. So this is the label. Scene 1, scene 2. So this is features. Okay. So this is features. So this is the label. The label is about the scene, fighting scene, shooting scene, fall scene, tension scene, and all those things. Then you got the features like this. So these features basically represent scene 1. You can name it the scene. Ghost, scene on the field. So this is the scene. The scene is a label. You name it to the label. Okay. So that basically about video. Okay. And so this is the process. Now when you have looked just now, so we look at the process, a process of supervised learning. So this process basically, it is the step that you must do for the supervised learning. Okay, compulsory for you. So you got 1, problem definition, data preparation, develop model, test, train, and model, assess experiment. So this 1, 2, 3, 4, 5 step basically you must remember and stick on your head when you do AI, machine learning, deep learning, or whatever. So this is remain the step mandatory. When you do the deep learning, supervised learning, or whatever, so this 1, 2, 3, 4, 5 step is a must. It's applied all the way on any application that you want to develop. Always apply this 5 step. Okay. All right. So the first is problem elimination. So the second is data preparation. Then we're going to develop the model, and we're going to train and test the model, and we're going to assess the performance. Okay. At the end of the day, you can say we have developed a model very accurate that can predict either we can play golf or not play golf. Okay. All right. So the first one is understanding the problem. It's important, You must understand the problem. If you don't understand the problem, then you don't know what kind of job to do, whether it's classification, regression, attack anomaly, and so on. So once you know the problem, once you know what you want to solve the problem, what application you're going to develop, then you can simply pick what data example you want to fit to for this project. It is a dog, it is a play golf, or it is COVID-19. So you can, if you have a COVID-19 problem, it's about identifying the COVID-19. So it is a classification whether COVID or non-COVID. So data that we're going to collect is X-ray. Label is COVID-19 or not. Okay, and pixel we're going to use and features we're going to use pixel. And then we're going to develop a model. In this case, we have many models to pick, but in this course, we're going to concentrate on this only. Okay, we're going to concentrate on neural network model. So this model is important, It's like a brain. When you have the model, you're going to train it. Remember you train? So say you got a 100 X-ray of COVID, so 80 will be for train and another 20 is for test. Train mean you let the computer, you let the model learn 80 image, learn from there. Okay, it learn from there. We're gonna train the model about 80 image, 80%, 80 image of this fallen. We're gonna, if we give the model 80 images, okay, 80 images, we got 100, we got, so you're gonna provide 80 images to the model to analyze each of the photo. Okay, you're gonna analyze each of photo until 80. And we know the label. So when he analyze the 80 photos, then we're gonna test it. How we're gonna test it? We have a 10, we take a 10, we just ask them, this photo is what? You're gonna ask the model, this photo is what? So the model gonna look at the what he has learned, 80%, and he can predict this is COVID-19. Then we're gonna look at the label. The label say about this is COVID-19, and the model predict COVID-19. So that is right. Then we give another photo until 10. 1 until 10. Okay. So we're gonna tell them, ask the model. Okay, model neural network. Ask, what is this photo? It is COVID-19 or not? So the model has analyzed, has got experience on 80 images before. He learned the characteristic of the features. Then he predict this is healthy. He said, not COVID-19, not COVID-19. The model predict this is not COVID-19. Not. Then we look at the label. The label say this is a COVID-19. So the model making a wrong decision because the model making this image is not COVID-19. But our database say that this is labeled as COVID-19. It is labeled as COVID-19, but the model predict this is not a COVID-19, so it's wrong. So the prediction is wrong. Okay, the prediction is wrong. So that means, so at the end of the day, how many you got right and wrong? If you got 5 right, 5 wrong, mean it is 50% accurate. If you all are predicting right, then you got 100% accurate. So when we said all 10 are the right answer by the model, we said that it's 100% accurate. That's mean assessing the performance. Okay. All right. I think we stop it here. Thank you very much, and